Hello everyone, this is Tuba Mirza and welcome to Recoding. All the code used inside this video are mentioned inside the description box. So if you like the work we are doing and if you're learning something from our videos, please do subscribe to our channel and share it with your group because your subscription will make this type of video happen in the future. So without any further ado, let's get started.
Showing a large amount of data inside the table is very easy to read and understand. Earlier in iOS devices, there were no native to show data inside the table. To do so, we need to use third-party libraries to show the data in an organized way. But with the introduction of the new table API in SwiftUI 4, it has now become very easy to show data inside a table with very few lines of code. Table was introduced in SwiftUI 3, but it works only with macOS. Now with this new API, it supports iPadOS natively. But you cannot use this API on iPhone devices. It will work, but now it shows only table first column. To use the API, we need to table a table view and add some parameters and finally add a closure. Inside the parameter of table, we need to provide data array, which we want to show inside the table. This data array should be filtered and data should be organized in the form of a structure in which the properties of the structure act as a column and data inside the structure will work now as a row. Apart from data parameter, we can also provide an optional selection parameter. This selection parameter will help the user to select a row inside the table. Final parameter of table is the sort order, which helps to keep the data in sorted order. User can tap on any column and it will sort all rows in ascending and descending order. For the selection parameter, we need to create a state property wrapper which will store a set of our data IDs and pass this state as binding inside the selection parameter. Similarly, for the order, we need to create a state property wrapper which stores the array of key path comparator which helps to sort data using values inside each of the rows in the column. Inside the table closure, we need to add a table column view which adds a column inside the table view. Table column view will take name and value as parameter. If we need to add any modification inside the table column apart from adding a simple text, we can do this by adding a closure after the table column parameter, and inside the closure we add a view which we want to show inside it. So this is how we can create a table using Table API. There is also another method to add a table by separating the column and row code. First, we can create a table column how we are creating earlier. Then we can add a row view and provide a row for each data we want to show inside the table. This is how we can separate both column and row code and use them as per our need. Our table view will look something like this. On the top side, there is a column title. While bottom to column title, we see our data. Let's now build an app using the new Table API. First, check out an alternative approach. Create a new SwiftUI view called Static Table. Inside it, create a structure called Purchase which conforms to identifiable. Inside it, add properties of ID and price. Then inside the body, create a table closure. Inside it, add a table column, add the title of the column and data which it should associate with the price inside the purchase structure. For another column, add another property inside the structure called inflated price which conforms to the integer. Then after table closure, add a row content inside it, add our row data. Add a table row view inside it, pass our structure and pass the prices. Then add the inflated price column also. Rotate our canvas view to the right side. Now add another table row as follows. Add more table rows and change the value of properties in each row. Add more table rows inside it by adding a for each closure. And now we can see that a table has appeared. Now let's work on a table app. We are building an expense management app which stores data such as expense name, its price and type of expenses, whether it is a credit or debit. Our final app looks something like this. It shows data inside a table. We can sort data by simply tapping on the column header. It automatically sorts data. User can also select the data and delete it if they want. Finally, user can create data by simply tapping the Add button. So this is what we are building in this video. We hope that you learn many things. Before we get ahead in our view, we recommend you to check our SwiftUI 4 playlist, which will have a new SwiftUI 4 navigation stack and navigation split view. Now let's dive into building our app. Inside the content view file, first create a structure called expenses which conforms to identifiable. Inside it, add properties of ID as UUID. Item name which conforms to string. Item price which conforms to integer. And type of expense. To add type to type of expense, we need to first create an enum. Create an enum for type of expense which conforms to int hashable, case, iterable, and comparable. Add two cases, one is credit while the other is debit. Then add ID which conforms to int of raw value. Add a localized name which conforms to localized string key. Then add a switch case to a type of expense enum and add a case of credit and debit and return a string. Then add a comparable protocol function which helps to compare the value of the type of expense based on its cases. First, let's return our left-hand side localized name to right-hand side. Inside the expense structure, add a enum of type of expense. Then create a class which consists of our demo data. Then inside the content view structure, create a state property wrapper, add a variable of expenses which equals to our example data class data array. Create another state property wrapper of select expense which equals to set of expenses ID and initialize it. It will store selection inside the table when the user selects each data. Then create another state property wrapper of sort order which equals to array of key path comparators, and initially it will only compare the item name. This sort order variable helps to sort the data according to each column data when the user press on the column header. Inside the body, create a navigation stack. Inside it, add vstack, then add a table closure. Add the parameter required by the table. First, add the expense array which we store inside the variable expenses. Second, pass a binding of selection which we create inside a select expense variable. Finally, pass the sort order as binding. Then inside the closure, first create a table column, add the name of the column, and pass the data associated with it inside the expense structure inside the value parameter. Then create another table column for item price and pass the value of item price from the structure. We can add some custom modifications to each table column by adding a closure after the table column parameter. Then inside it, create a constant for a data value for each data inside the column. Then add a text view by adding a dollar sign before the price of an item. Finally, create a table column for the type of expense. Inside the table column closure, create a text view localized for each of our expense. Then create an if block to check that if the type of expense is credit, we are going to show a text view with green foreground color. And for debit, we are going to show red foreground color. Below the table closure, add on change modifier, which will take our sort order variable to check. This will sort our expenses array according to the table column selected by the user. For comparing the type of expense column inside the type of expenses enum. Inside the comparable function, add left-hand side raw value is less than RHS raw value. This will now sort our type column according to debit and credit. Add navigation title modifier and add table view as title. Below the table closure, add an edge stack. Then add a text view to show the total number of entries inside the expenses array. And add another text view to show how many items are selected by the user. Add some padding to the edge stack. Now let's work on adding some data from the user. To do so, first create a sheet view. Create a state variable of isSheet which initially is false. Then add sheet modifier below the vStack closure. Add isRepresented parameter as binding of our isSheet variable. Then create a new SwiftUI view called addExpense. Inside the view, require a variable of expenses as an array of expenses structure. Then inside the content view sheet, pass our expenses variable. For the preview, create a state of the static variable of expenses which will have data from our expenses data classes. And pass it inside the preview. Here inside the sheet modifier, we need to add is represented, not is an item. Then inside the add expense body, create a navigation stack. Add a form view. Then add a text field of item name. Likewise, create another text field for the item price. Finally, create a picker view for choosing the type of expense. Inside the picker view, add a for each view inside the parameter, add a type of expenses enum and pass all the cases. Then for each case, we are going to show a localized name as text view. Add a tag modifier and pass the expense constant inside it. Add a navigation title modifier. Below it, create a button view, add a label view inside it and add text and system image. Create a state to store the value of the item name as a string. Create another state to store item price. Finally, create a state to store the type of expense which conforms to the type of expense enum and initially it is set to credit. And these create state as a binding inside each subsequent text field and picker view. For button action, we create a constant which equals to our expenses structure. Add initializer and pass the value inside it. Then add the constant inside the expenses array. Add key type inside the price field as a number. To make a change inside our array inside the class, we need to set our class to an observable object. Add the variable example data array as a published value. Then initiate our expense data class as a state object. and pass this as an environment object inside the add expense view. Inside the add expense view, we require the expense data class as an environment object from the previous view. And pass environment object inside the add expense view with expense data class initializer. Here inside the expense data class, we need to add an observable object, not an observed object. Now we append data inside the example data array. Now we need to add our expenses data array inside the value of each expense we use. Finally, create a toolbar modifier. Add a button to open the sheet view. Inside the Add Expenses view, add an environment object of dismiss. And add dismiss function inside the button action. Here we can see that now we are able to add data inside the table. Now add a function to delete data from the table. To do so, create a delete button inside the toolbar. Add toolbar item view and set the placement to the primary action side. First, create an edge stack. And add our add button and delete button inside the edge stack. For the delete action, we need to create a loop for our select expense set, which already stores the ID of each data. Then we create an if-let index which equals to expenses array, and we use the first index function and pass our where attribute to match the ID. If the ID match, we can now remove the item inside the array using the array remove function and pass the index as an integer. Finally, we make our select expense state as an empty set. Now let's check our app. Now we can see that we are able to sort the data and add new data. Delete data according to our need. Now run the app inside the simulator. So this is how we use table inside SwiftUI 4.
Recoding is on Patreon and Buy Me a Coffee. Make a small contribution or donations to help us grow our medium. We still offer free content on YouTube and other writing platforms. Also, don't worry, there are other ways to support us. Share us on Facebook, Twitter, and other social media formats with your friends and ask them to subscribe. The links are inside the description box. And yes, let us know what you liked or disliked about this video in the comment section. Please do like and subscribe to our channel. And yes, do not forget to suggest some more topics. For now, I'll be signing off. We'll definitely see you all in the next video.